It's not. OK, here we go. All right, thank you, everybody. My name is Robert Elwell. I'm a senior software engineer at Wikia. This is my presentation, MTO on Blast, using language models to identify endemic constructions in a hip-hop gossip blog. So let's first talk about what we're going to cover in this talk. This is going to be a light introduction, emphasis on light, to computational linguistics and natural language processing with Python using the Natural Language Toolkit. A little bit of light web mining is involved. And my hope is that if you're a total beginner at any of this, you should walk away with a conceptualization of the many layers and nuances involved with text processing. Before we go any further, I have to issue a parental advisory. This talk includes explicit rap lyrics and gossip headlines, so fair warning. And now a little bit about myself. I'm a computational linguist, NLP and search expert. I cut my teeth on Python in grad school, UT Austin, doing a lot of machine learning around discourse parsing and things of the like. I manage Wikia's search stack, which uses a Python backend, and we're kind of growing our Python repertoire here at Wikia. And of course, hip-hop enthusiast. So what does that mean, hip-hop enthusiast? Well, I'm a regular contributor to the Rap Wiki. I get my mixtapes from DatPiff, I get my videos and industry news from World Star Hip Hop, and all of my juicy gossip from Media Takeout. So this is MediaTakeout.com. It's got a style all of its own, and it's a very exciting domain of language. So let's kind of dive into what Media Takeout is. It's got a lot of unique constructions as far as any kind of a blog goes. The headlines are really exciting, and they have a trademark tone and kind of a grammar all of their own. And of course, it sensationalizes everything about my favorite rappers, which makes it interesting enough for me. So this is really all about a scheme to entertain myself. I decided I wanted to create a headline generator that mimics the headlines from Media Takeout. So then I would take those headlines and build a tribute site for my favorite gossip blog. And hopefully, in doing so, discover what makes the corpus of text interesting and what constructions are endemic. So this is really just me mashing up the two things I like the most, hip-hop and natural language processing. So let's get some examples of what Media Takeout's headlines are so we actually know what we're looking for. Told you so. Rapper French Montana confirms that he and rapper Trina are dating. Pics and video. Balling. Lil Wayne's father, not really his father, Brian Birdman Williams buys a $4 million Lamborghini, and we've got pics of his new ride. MTO world exclusive. Rapper A$AP Rocky's celebrity girlfriend dumps him and then removes the tattoo he got of his name. I guess maybe just shouldn't have gotten the tattoo, huh? So let's look for some patterns in these short examples here, right? Ellipses are used for effect. The headlines are usually introduced with an exclamation. There are parenthetical asides that advertise pics and videos and how much you won't believe what's in there. And then, of course, hip-hop celebrities are a common subject. So what's a headline generator, and how are we going to make one out of MTO? So a headline generator basically randomly applies rules from a grammar to create a headline. In other words, this is just your run-of-the-mill language generator. A grammar, then, is a mode of defining what a well-formed sentence is. So we've got a couple of ways to do this. We could do this using a context-free grammar. For those of you familiar with the Chomsky hierarchy, it's kind of one up from regular expressions. You would basically manually write a series of rules to enforce how these different classes of words and groupings are ordered. You would start with terminal nodes and work your way up until you got to a sentence, for instance. Another option would be to use statistical knowledge of the corpus in order to sort of randomize the sequence of words using just probabilities and not strict rules. So let's kind of start looking at CFGs first, because I think that's the easy one to do. This is an example of a parse tree using a context-free grammar. Any of you who've taken an intro to linguistics class might be familiar with this. So the house at the end of the street is red. We have determiners, nouns, prepositions, verbs, and adjectives, right? These are expressed using part-of-speech tags, which in this case are D, N, V, P, and A. And those are satisfied by these strings to the right of it. in order to create rules that build up to a sentence, we apply higher level rules that are ultimately satisfied by the combinations of these words until we arrive at a sentence. So as you can see here, we're building up noun phrases which can be consumed by other kinds of noun phrases or prepositional phrases, and then verb phrases, ultimately in order to combine a noun phrase and a verb phrase into a sentence. And we know that a sentence is kind of where you stop parsing. So in order to create a CFG for generating text, that would kind of be a lot like writing a Mad Lib and then just randomizing what the entries are, right? So you would basically determine what the terminal nodes are and then build out rules in order to do that until a sentence is created. And then obviously, we don't have to follow the rules of strict Chomskyan English grammars. We can just build a domain-specific CFG. This is just a data type. It's a data type applied to natural language, but you can use it in a lot of other things. So in this case, we're going to randomly pick a value that would satisfy a rule until you get to a sentence. So we have a script here that you can access on GitHub, and this is what it looks like. We have interjections, wrappers, predicates, the picks part, and the ellipses part. In order to get a headline, right, we basically want sort of a randomized value for an interjection, a headline, ellipsis, and predicate, which is sort of a nested rule, right? And then ellipses again, and then the picks aside. So what I've done here with ellipses to make them optional is make some of the members of the list an empty string. So let's see what kind of output we'd get for that. Yikes, Kurt Cobain puts jump off on blast on Twitter, and we got a video. That's like almost exactly what that kind of, the kind of headlines we get. Bling bling, Rick Ross buys a new Bugatti, pics inside, I'd like to see that. Okay, so moving forward. What are the drawbacks of using a rule-based approach, right? You have to write every single rule. Not only that, but you have to write the entire lexicon. The fans over at Stanford of LFG might be cool with this, but an engineer probably wouldn't. So you really wouldn't see anything. You have it mostly hand-coded, which is not fun because, sort of the goal of at least this specific engineering task is to entertain myself. So language models, on the other hand, basically use sequences of words and the probabilities around the prior sequences in order to assign what is the most probable upcoming word. We can then sort of map the probabilities randomly to a value and then say, oh, well, we had a 30% chance of this word, a 10% chance of this, map it to random 0 to 100, and then see what we get. So when we talk about this, we want to say it in the context of n-grams, where the order of n-gram refers to the number of adjacent words. So a unigram would be 1 word, bigram would be 2 adjacent words, trigram would be 3, and then we start just using numbers, so 4gram and so on. So a trigram language model would then identify the probability of the next word given the previous 2 words. So we actually use probabilities when we are listening to people and anticipating what they're about to say. So here's a little bit of an exercise. Where's the beef? Who's the... There we go. All right. So tokens versus types. This is another very important thing to understand when we're working with natural language processing and language modeling. Basically, each unique word in a text is identified as a type, right? And then every time we count one of those types, we consider that a token, a unique instance within the text of that unique type. So as a bit of an exercise here, a dog is a dog, once said Will Smith. Let's kind of get the type and token count here, right? So we've got 3 types, right? 2 of them have a token count of 2. 1 of them has a token count of 1. So that allows us to start talking about Ngram probabilities now that we understand types and tokens. So the unigram probability of a type is its token count divided by the count of all other tokens, right? And then once we start getting into Ngram probability, we start saying, what's the probability that the following word will show up given the prior n words, right? So this is actually the formalization of that. As you can see, there is some math involved, I'm sorry. So let's kind of get an exercise in probability so we know what we're in for as we move forward. Gold all in my chains. Gold all in my rings. Gold all in my watch. Don't believe me, just watch. Trinidad James. So does anybody know, looking offhand, what the probability that the first word of any given sentence is gold? 0.75. How about that the last word of the sentence is watch? 0.5 indeed. And then finally, what's the probability that the last word of the sentence is watch, given all in my? All right, that might be a hard one, it's 0.33. So what do we need in order to make an interesting language model? Well, you've got to start with data, right? No, you've got to start with a lot of data, because if you don't have enough, then it starts making sort of crummy predictions and it really starts repeating itself. And of course, an interesting domain space always makes this kind of stuff more entertaining. And then finally, we need to get the data. So let's have a methodology for accessing and then processing that data up front. So I've been talking mostly about the sort of language modeling part, but it's actually a multi-part problem then, because we want to get the data from media takeout. We have web mining or screen scraping, which is extracting content from an HTTP accessible data source. And then we have language modeling. If you don't know, now you know. So web mining is basically accessing HTML from a script and using selectors to access the text therein. I even access pagination information in order to know what the limit is, using sort of the archive URL schema that MTO has provided. So then I would write the headlines to a flat file, new line separated, and then move forward from there with my data. So you can see this in mtoscrape.py in my GitHub repo. And here's basically what we've got going on there. I'm using an access of the limit value the first time I access the archive in order to get the limit of pages. And then as I start iterating from page 1 to whatever the limit is, I continue using the same definition. So I'm reusing one sort of subroutine to handle this. So once we do that, we have our headlines.txt all ready to go. So what did we get from that? We got about 40,000 headlines, averaging 16 words and 96 characters per headline, so this is totally going to be tweetable. And then we have a decent amount for a trigram language model. I tried with bigrams, it wasn't that great. I tried with 4grams, and there just wasn't enough data. So now we're at the point where we start having to tokenize the actual headlines that we have in our text. So basically, a body of text needs to be fit into data types, right? So you would want to first tokenize this text for sentences in order to get each string that represents a full sentence. And nltk.tokenize will allow you to do this. So the sentences are then just strings, right? But we really want the words, so we also need word tokenization. So, DJ Khaled says, "we the best," but we don't know the word we, the word the, or best without that. Another interesting component that we're not really going to use with our model, but is worth mentioning, is that you can also filter out stop words, so functional words that are highly common in a body of text, but aren't necessarily interesting. So here we've got "we the best," DJ Khaled's hit, stop word filtered out to just "we best" in a very strict set of stop words. So now frequencies become sort of the most interesting and engaging part. NLTK's probability module allows you to get an understanding of what these frequencies are up front. So the frequency distribution class allows you to sort of give it a set of tokens in an array, right, or a list as it were, and get the topmost frequent tokens by doing freqdist.items, and it will actually give it to you sort of sorted by frequency, descending. So these frequencies are important to understand because they'll influence what model will generate, and so we can analyze those further on using this MTO analyze. So basically, I've assigned a function that determines whether or not a token is alphanumeric, which suggests that it's probably going to be a word, and that the token is not a stop word, right? So then we have a file that we're iterating over. We're tokenizing out the sentences, and then appending that to a list of sentences. And now that we have all of our sentences, we want to create all of the tokens from our corpus based on tokenizing each sentence and adding that into the list. So now we can actually create bigrams and trigrams by iterating over these in a list comprehension and doing, sort of position +1, position +2 until we get to, the very end of the list -2. And for bigrams, the very end of the list -1. So we can then analyze the frequency distributions and print out a descending list of our most popular tokens. There was supposed to be a slide that showed you what the frequencies are, but apparently it's gone. Basically, you find interesting constructions such as photoed and MTO world and world exclusive and things like that. MTO world exclusive is apparently like the way they introduce almost all of their headlines. So it's pretty interesting, but I think you'll get the flavor for what we're going for once we hit the actual examples. So looking at the NLTK text class, this is a really good one for exploring a corpus without having to go into any of the other stuff that we just talked about, because we can pass a flat string into it and it will do all of these computations for us. It actually also has its own language model functionality, but we want to have a little bit more degrees of freedom when we're experimenting. So we actually go a level deeper and use NLTK's Ngram Model class so that we can not only vary the number of Ngrams that we want in our generations, but so that we can apply smoothing to them. We'll get to smoothing in a second. So the Ngram Model class basically says, give me an order of Ngrams. Is it bigrams, trigrams, 4grams? And give me one of these instances of text where everything's already kind of been encapsulated and that knows how to do it, right? It's interfacing via the APIs. It's not doing anything to the text. And then you can give it a probability estimator for smoothing. So, what's smoothing? That allows us to approximate the probabilities of unseen instances in our probability distribution, and that kind of adds randomness and, things that we haven't seen before. So that means that we're actually going to be getting novel constructions based on some of the prior probabilities of our corpus. So we tell the model, give me between 5 and 25 words, and then print it out, right? And that's MTO language model.py. So this is the script for that. We're loading in a pickled file, a pickled construction that we saved during the MTO analyze script. We send this data to nltk.text, and then we use a lambda to create a probability estimator that will then be applied across our probability distribution. So now we have our Ngram model, and that's basically exactly the constructor arguments that I previously said, the Ngram order, which was passed in via the argument parser, the text class, and then our estimator. So then finally we use a list comprehension and a string join in order to write out a number of sentences that we've generated, either to standard out or pipe it to a flat file, and then based on whatever limit we apply. So here are some of the example headlines that we get from this. MTO World Exclusive. LeBron James is getting the leading actress in Dreamgirls. Grammy singer gets to remain on the shaved head. MTO World Exclusive. Chris Brown photoed with a little late next month Kelly Rowland out and about, meeting Jesus. MTO World Exclusive. Kanye West died in a deadly Buffalo, New York plane crash. Really happy that didn't happen, guys. MTO World Exclusive. MediaTakeout.com. Perez Hilton and Jay-Z steps down from office. John McCain refuses to make me look. So here are some stray observations from our output. MTO World Exclusive isn't like every headline, right? I went through 50,000 lines and all of them started with some version of MTO World Exclusive. The sentences aren't totally grammatical, but that's because we only asked for between 5 and 25 words, right? We didn't say give me a grammatical sentence. We didn't say stop when you hit a period or stop when you hit something that suggests the end of a sentence. One way we could make more grammatical sentences is if we applied a filter, right, that used a CFG in order to say whether or not this could be parsable as a sentence. The problem with that is you then have to do some part of speech tagging, which is non-trivial, and then you actually will have to write a CFG for this because this is not, your standard brown corpus way of parsing English, right? So these constructions are really kind of prevalent and endemic to what the output is. So what you're seeing here is what you'd see here if you went to the media takeout headline generator site and hit refresh a whole bunch of times. So speaking of the generator site, this is just a PHP script that I wrote that grabs a random line from a file via shell. And then I added in a search capability that first, greps all of the outputs that involve that searchable phrase, and then randomizes that and grabs a random example from that search. So you can actually check this one out at my media takeout headline generator site, and content advisory definitely applies, guys. And here's what it looks like. MTO world exclusive, CNN news anchor Soledad O'Brien photoed taking a roller coaster. Sounds like a lot of fun. So what did we get from doing this, right, other than entertaining myself to no end? We learned that even a toy application of NLP can show how really complex everything is involved in. There's a lot of layers to this when you start with a string and want to get to real data surrounding what constitutes language. And NLTK is a really good way to start using this kind of stuff. It's got a free book, it's got all kinds of resources, and one of the coolest parts is that once you finally sort of cut your teeth on understanding what these do, you can start looking at the source code to get a really good idea of what the underlying algorithms are involved in here. And you'd be well on your way to becoming a computational linguist too. So language models can be a really fun way to figure out, what constructions make a corpus have a specific tone or a sense of authorship. And that's my talk. If you're interested in learning more about this, please feel free to come talk to me. We're currently looking for interns for search and NLP stuff at Wikia, doing some Python stuff. You can check out the MTO headline bot on Twitter or follow me. Thanks very much, guys.
Thank you very much. If you have questions, please step up to the microphone. If you want to know more about entity recognition, latent Dirichlet analysis, and other good NLP fun, there will be a BOF in the Great America Meeting Room 3 at 7 p.m.
So you said that the sentences that it came up with weren't 100% grammatically accurate. It seems that in order to push them across that boundary to actually make them 100% grammatically accurate, you could just add like a relatively simple part of speech checker. But so this is something that I've run into in my own work, is that like needing to check the part of speech of a word is actually like basically programmatically impossible unless you have an enormous database of those things. Is there any like dictionary site that has an API that you use or recommend to do such work?
Not really. Parts of speech are a really complicated sort of sub-area. I'm actually kind of a fan of more type-based approach to syntactic parsing. And then, if I were to apply something like that, especially to a corpus like this that, some people would argue may not be grammatical, they'd be wrong, but they would argue that. I would apply an unsupervised learning algorithm in order to determine sort of what types are consuming what other types, and then apply that and use that to kind of enforce constraints against this language model.
Thanks.
When you tokenized, you took out the articles of the functional uninteresting things.
Yeah, sorry. I should say I didn't. That was an aside for analyzing some of the stuff. Yeah, it wouldn't have shown any articles if that were the case.
That's what I was wondering, is why they showed up. Okay.
Hi, so I recently built a language model from the Wikipedia download. It was like a 30 gig text file and ended up with something like I think 5 or 6 gig ARPA text language model. Mm-hmm. I had a really hard time actually loading that into any of the toolkits I was using. Could you recommend, one of the questions I had, would I have a better, if I actually, so I only did a trigram model. Yeah. Would it be better to actually go to a 4 or 5 gram model? And what toolkits should I look at to actually be able to load that?
So is your question that you're looking to increase the order of n-grams for your model? And
well, I guess my question is, should I?
Should you? Well, it depends on the amount of text you have, right? Wikipedia has a whole lot of text. Google has more, right? I think I could be totally wrong, but they kind of start with 5 grams and work their way up with a lot of their modeling stuff. But the scale of Wikipedia compared to the scale of the entire internet, right? So I would suggest experimentally working with different orders of n-grams until things start looking more grammatical to you. Again, applying syntactic parses to this and then doing, what's my percentage of grammatical to ungrammatical sentences might be a good way for you to start experimenting with where should I increase my n-gram order and where should I decrease it.
Thank you.
A slightly related question. I was working on something along these lines, like a Markov random field text generator, and rapidly kind of ran into problems storing all of the Ngram models. I was wondering if you had any luck integrating NLTK with some sort of external database so I can fit frequency models that are too big for memory.
Not really something that I've worked on. It sounds like you're going down the right path, though, by starting to look at integrating a database with it, right? But then, of course, the issue becomes I need to start pulling out probabilities from the database each time, right? Mm-hmm. So that could get convoluted because you start going deeper and deeper into NLTK's rabbit hole.
Yeah, thanks.
Thanks very much, guys.
No, one last question.
Oh.
Can we start calling unigrams words?
Yes.
Robert Elwell, everyone.